Welcome, it is Ramchandra from Civil MECH Maths Concepts channel, in which it is the 19th lecture in structural analysis, useful for both SSC JE and GATE examinations. These lectures will be useful even for UPSC engineering services examination also. And in the last lecture SA 18, I have discussed about the deflection in cantilever beam. Finding the deflection in a cantilever beam subjected to a point load and also a moment at the free end with the help of moment area method. Now we will go for finding the maximum deflection in a simply supported beam where the total length of the beam is L and from left hand side support the distance is A and from the right hand support the distance is B. A point load P acts at a distance A from the left hand side support. We have to find the maximum deflection. It's not the deflection under the load. We have to find out the maximum deflection. The point of maximum deflection is different from the point of application of the load. It depends upon the maximum deflection depends upon the A and B and also L, length of the beam. And the equation for the maximum delta max is equal to PB by 9 root 3 L EI into L square minus B square to the power of 3 by 2. This is the equation which we have to derive. This is the target for today's lecture. Let's go into the details. In this, I want to use the integration method. In the last lecture, I have used the moment area method. To get the concepts of the moment area method, please see my previous lecture, SA 18. In this, I am going to use integration method. There are two methods with which we can find out the deflection of a beam at any point on the beam. The one is integration method, another is moment area method. Moment area method I have already explained. Now in this we will go for integration method. By integration method, let's go for integration method. We will use our mathematical skills in integration which we have learnt in our HSC higher secondary examination, higher secondary course or any mathematical course, pre-university courses. We have studied about the integration and differentiation. We will use that method to find out the maximum deflection, the point of maximum deflection and also the maximum deflection delta mx. Where this delta mx acts, maybe delta mx acts here, we are not aware, we will find out now, and also the quantity of it. Let's go into the details. What is the equation of the beam theory? Beam theory states m by I is equal to sigma by y is equal to E by R. This is the beam theory equation. From beam theory equation, for finding the deflection, I have derived an equation which you can use it freely for any support, any type of beam, and which I explained in my previous 18 lectures you can refer to my previous lectures on beam stresses and structural analysis, the 18 lectures, and in one of them I have explained about the equation of the beam theory. Now this is the beam theory, and I explained in detail even the integration formula. What is that integration formula? As per the beam theory, please recollect. When you recollect, the deflection of beams, or we have rather regarding this radius of curvature, I have given a formula in the beam theory which directly related to the deflection in curves. Which we had a formula. Please remember that formula. Please write it. Deflection, let us say delta x. Here this is the beam given, this is the load P, this is B, this distance is A, the total distance is L. Initially let us find out the SFD. What SFD says? As per shear force diagram or shear force calculations, we can say this is RA, this is RB, reaction at A and reaction at B. RA plus RB is equal to P, that is the first reaction, because the vertical downward forces equal to vertical upward forces. What are the vertical upward forces? RA and RB. What is the vertical downward force? That is P. RA plus RB is equal to P. Then taking moments about A, that implies P into A. P into A, P acting about A, the moment it is causing a moment clockwise, P into A. Whereas R into B, RB it is causing, this is A, this is B, RB is causing an anti-clockwise moment. Okay. Now taking moments about RA, the clockwise movement should be equal to the anti-clockwise movements, because total movement at simply supported beam, at the support the total movement will be 0 at the free support, that is a RA, that is the end support. At the end support, the movement at the end support in a simply supported beam is 0. That means total vertical movement will be equal, total anti-clockwise movement will be equal to total clockwise movement. What is the anti-clockwise movement? P into A. Implies P into A, that is the anti-clockwise movement because of P. And what is the, this is clockwise movement. What is the anti-clockwise movement? This is caused by RB. That is equal to RB into L. That means P into A is equal to RB into L. That means reaction at support B is equal to PA by L. RB is equal to PA by L. Now, what is RA plus RB? This is equation number 2. RA plus RB is equal to P. That implies RA is equal to P minus RB. That is equal to P minus PA by L. That is equal to P into L minus A by L. That is equal to PB by L. Now, what are the reactions we have got? The beam will be like this. RA is PA by L. RB is RA is PB by L. PB by L. RB is equal to PA by L. And P is acting like this at a distance of A from right hand side, at a distance of B, and from left hand side at a distance of A. This is A, this is B. This is a final loading on the beam. RB is equal to PA by L, RA is equal to PB by L. Now we have got the forces. Now, deflection. Now what is the bending moment? We have to calculate the bending moment at different places. What is the bending moment? Ultimately we are interested in the BMD. Let us try to draw the BMD. What is the bending moment at point A? At point A, bending moment will be 0. MA is equal to 0. As I told you, in simply supported beam, at the end support, the moment is 0. Here also, the moment MB is equal to 0. MA is equal to 0 and MB is equal to 0. Next, at a distance x from one end, let us say left hand side end. At a distance x from left hand side end, what will be the bending moment? This bending moment will be left hand side, PB by L in the clockwise direction. That means PB by L will be acting like this because of PB by L, because of the reaction. It goes up to P. Then what will be the bending moment diagram? Please tell me. This is positive. This in between, let us say at a distance of x from here, mx is equal to, I am only writing the values now, mx is equal to PB by L into x. Do you agree? Up to the distance between zero less than or x equal to less than or a, mx. Then after the second portion, first portion is this. If x is beyond this, x goes beyond this, beyond P, what happens? This is x. That means mx is equal to PB PB by L into A, because X has already crossed A. We will say into X. PB by L up to distance of X, it will be PB by L into X. And because of this P, how it is causing the moment? How P is causing the moment? P is causing the moment in the negative direction. This is minus. P is causing the moment in this direction. What is the distance? Distance when it is X, this distance is X minus A. That means minus P into X minus A. This is for A less than or equal to X less than or equal to B. Not B, rather it is up to the end. Up to the end. A plus B, rather it is L. These are the two moments. We have to write the equation for the moment, and this equation we will use in the beam theory equation. M by I is equal to sigma by Y is equal to E by R. Now, we have found Mx is equal to PB by L into X for 0 less than or equal to X less than or equal to A. Mx is equal to PB by L into X, it is minus P into X minus A for A less than or equal to X less than or equal to L. These are the two equations we have got. What are the boundary conditions? MA is equal to 0, MB is equal to 0. These are the two boundary conditions for a simply supported beam. At end supports, the moment is 0. Now, how to use the beam theory equation to find the deflection, which I have explained in my previous classes. M by I is equal to sigma by Y is equal to E by R. From this, if delta X is the, please make a note of this equation. If delta X is the deflection, if delta X is the deflection, if delta X is the deflection at X from left support, let us say, from any support we can take left support, then what happens? What is the equation? From the beam theory, we found that because M is already known, I is known to us, E is a material property is known to us, I is a cross section we know, Mx is known. Then from radius of curvature, which I have defined in the previous classes, from that we can say that Ei into d square delta by dx square is equal to mx. This is the equation which we have derived in our previous videos. Again, let me write it for clarity. This is a very important equation. As per beam theory, m by I is equal to E by R. Let us forget about sigma by Y. E by R is related to deflection. Deflection and radius of curvature, which I have defined already in my previous lectures. E is Young's modulus, I is second moment of area or moment of inertia, you can call it as moment of inertia. M is bending moment. Now bending moment is known to us. From this definition, we get an equation in differential form, a differential equation, E into I, m by Ei is equal to 1 by R. Do you agree? Or we can say Ei into 1 by R is equal to m. From this, we will get the deflection as Ei into d square delta by dx square is equal to mx. This is the very important equation. Please remember, d square delta by dx square is nothing but 1 by r. That is from the geometry. You can refer to my engineering mathematics videos also. From the radius of curvature, we can define it. Ei into d square delta by dx square. In some books, we say that d square delta x we can say, because when we are defining at x everything, d square delta x, because deflection also varies along the length of the beam. The delta x in some books it is written as Vx. This also you can consider. That means in the examination if it is given Ei into d square delta x by dx square is equal to mx, that can also be written as Ei into d square Vx by dx square is equal to mx. Both are correct. Both are only notations. Don't worry about the notations. Try to understand the concept. Both are correct. Can you call it the deflection as delta x? That's up to you. Or you can call the deflection as Vx. That's up to you. You can either do it. There is absolutely no problem. Now ultimately what we have to find out is delta, and that to delta maximum. Once we find out the delta x, then we can find out the delta x maximum. Now, from the above equations, we can write d square delta x by dx square is equal to mx by Ei, or d square Vx by dx square is equal to mx by ei. Either you call it Vx or delta x, that is up to you. It will be convenient, I want to call it as delta x. Let me call it as delta x, absolutely no problem. That's up to you. Now I got the equation. What is mx value? Mx is equal to Pb by L into x for 0 less than x less than or equal to a. Mx is equal to Pb by L into x minus P into x minus a. This is for a is less than or equal to x is less than or equal to L. For these two values we have to find out the delta x. Now what is delta x? Delta x is equal to, let's not directly go for delta x, we'll put the values of mx in this equation. D square delta x by dx square is equal to mx, that is Pb by L into x into 1 by ei. Or you can simply take it as ei for convenience sake, ei into d square delta x by dx square is equal to Pb by L into x. It's a differential equation. When we integrate this equation, let us integrate. What happens? On first integration, what happens? Ei into integral d square delta x by dx square dx is equal to integral Pb by L into x plus some constant C1. That implies d square delta x by dx square into dx is that once we do integral, what happens? This becomes d delta x by dx, ei into d delta x by dx, left hand side. Then this will be integral x, Pb by L will be common, this is constant, integral x dx. What are the limits? Limits are for this Pb by L into x 0 to a. Because the limits are 0 to a plus C1. That is first integration. Now we will integrate again, because we have to remove this here d delta x by dx also. We have to integrate again. Integrate again. That implies when you integrate again, d delta x by dx will go and delta x will overlay will be there. Ei into delta x is equal to left hand side Pb by L What is integral x dx? Integral x dx is nothing but x square by 2 plus c1. Now integral x square by 2 dx plus integral c1 dx plus another constant, integration constant c2. That implies EI into delta x is equal to PB by L into x cube by 3 into 2 is 6. X cube by 6 minus C1 plus C1x. C1 dx will be C1x plus C2. This is the integration constant. Now, what happens here? For the distance EI into delta x is equal to PB x cube by 6L plus C1x plus C2. This is the equation 1 for 0 less than or equal to x less than or equal to a. We are considering the first portion, left hand side first portion. Now, what is the boundary condition? At x is equal to 0, mx is equal to 0 and delta x is equal to 0. Deflection is also zero at boundary condition, left hand side support. Now what happens when you apply this in the equation 1? EI delta x is equal to PB x is 0, 0 cube divided by 6 plus C1 into 0 plus C2. Because deflection is equal to 0, at that this will be 0 plus 0 plus C2 is equal to 0. That means the constant of integration C2 value is 0. That means the final equation for the deflection will be in the portion PB x cube by 6 plus C1x plus 0. This is the equation 0 less than or equal to x less than or equal to a. Now, we are still unaware of the constant C1, but we have another constraint is that another application is that delta is equal to 0 at A and at B also. Moment is equal to 0 at A and at B. We have only tested the equation only for the portion left hand side, left hand support. A is less than or equal to x less than or equal to L. That implies what is mx value? Mx value is PB by Lx, PB by L into x minus P into x minus A. This is nothing but d square delta x by dx square. EI into d square delta x by dx square is equal to, in this portion, PB by L into x minus P into x minus A for a less than or equal to x less than or equal to L. That is for the second portion. Now, for this portion, same as the previous equation what we have done, previous portion, in the similar way we have to find out the deflection. Now, integrate once. This implies once we integrate, what happens? EI into d delta x by dx is equal to PB by L into x square by 2 minus P into x minus a whole square by 2 plus some constant C3, integration constant. Integrate again. Integrate second time. That involves d delta x by dx EI into EI, let us not forget, PB x cube by 6L minus, as in the similar previous step, P into x minus a whole cube by 6 plus C3x plus C4. For integration and other things, you please refer to my previous lectures, how we are doing it. Now, what is the boundary condition? M at B is equal to 0, delta at B is equal to 0, x is equal to L at B. That implies when you integrate for the second term, this d delta x will go and it will become only delta x. Delta B is equal to 0, that means EI into 0 is equal to PB into 0 cube by 6L minus P into minus a whole cube by 6 plus C3 into 0 plus C4. From this, you can find out the C3 value. X minus a whole cube, that is x is equal to L, L minus a whole cube, x is equal to L we have put, and here x is equal to L, it is not 0, EI into, this is 0, delta x, PB into, x is not 0, sorry, x is equal to L, PB into L cube by 6L minus P into L minus a whole cube by 6 plus C3 into not 0, it is C3 into L. From this, what is L minus a? L minus a is equal to B, because a plus B is equal to L. Can we write this equation as 0 is equal to left hand side, PB L cube by 6L minus PB cube by 6 plus C3 into L plus C4? That implies 0 is equal to PB into L square by 6 minus PB cube by 6 plus C3L plus C4. The deflection at A from the previous one. What is the first one? EI delta x is equal to but at A, at x is equal to A, the slope and deflection are continuous. Because when you go from left hand side and when you go from right hand side, there should not be difference when there is at A. At A, when you use the first equation or the second equation, the value should be same. For example, at x is equal to A. This is another equation. This is the second equation. The first equation is what we have got? First equation, EI delta x is equal to EI delta x is equal to first equation PB x cube by 6 PB x cube by 6 plus C1x. This is the first equation for 0 less than or equal to x less than or equal to A. And second equation is EI delta x is equal to PB x cube by 6L minus P into x minus A whole cube by 6 plus C3x plus C4, which implies EI delta x is equal to PB x cube by 6L minus PB cube by 6, because x minus L minus A we have taken it as B. Let us not write x L minus here, let us take it as x only, afterwards we will apply whole cube by 6 plus C3x plus C4. Here how many constants are there? To find out, 3 constants. One is C1 and another is C3, another is C4. At x is equal to A, EI delta x, both the values should be equal to same. Let us put x is equal to A. Let us put at x is equal to A. Because the deflection cannot be different when you approach from right hand side or left hand side. At x is equal to A, from the first equation we get EI delta A instead of delta x. PB A cube by 6 plus C1A. And similarly, when you apply the second equation, EI delta A is equal to PB A cube by First issue P by A cube by 6L in both the equations. This is L. PB A cube by 6L. Here also PB A cube by 6L plus or minus, we can say minus, P into X is A minus A whole cube by 6 plus C3 into A plus C4. You just see. Let's compare these two now. This is gone because A minus A is 0. This is equal to 0. Now PB A cube by 6L, PB A cube by 6L. It is valid. Now C1 into A, C3 into A. That means C1 is equal to C3. C4, in the second equation there is a C4, but in the first equation there is no C4. That is 0 into C4 we can say. Or we can say there is nothing called, we will say it is 0 only. That means C4 is equal to 0. C1 is equal to C3 and C4 is equal to 0. Now equations, what happens? Equations will be EI delta X is equal to PB X cube by 6L plus C1X. This is one equation between 0 less than or equal to X less than or equal to A, and EI delta X, that is equal to PB X cube by 6L minus P into X minus A whole cube by 6 plus C3 X. This is second equation. 0 less than A less than or equal to X less than or equal to L. Now we will apply the boundary condition at L is at L. Apply boundary condition at L. Now for this new equation of 2, apply boundary condition at L. Applying boundary condition, apply boundary condition at L, at the second end of the end support of the simply supported beam. M is equal to 0, delta is equal to 0, ML is equal to 0, delta L is equal to 0. That means what happens? EI into delta L will be, delta X will be delta L, that is equal to 0. And what will be equation, second equation, PB into L cube by 6L minus P into L minus A, X is equal to L, PB into L minus A whole cube by 6 let us write it clearly, P into L minus A whole cube by 6 plus C3 into L. This implies 0 is equal to PBL square by 6 plus L minus A is equal to B, which we have seen earlier. This will be minus, this will not be plus, this will be minus PB cube by 6 plus C3L is equal to 0. That means PB by 6 into L square minus B square plus C3L is equal to 0. When you take this onto the other side, from this C3 is equal to minus PB by 6L into L square minus B square. We have got this. C4 is already 0. Now, we have got the deflection equation as EI into delta x is equal to, first equation, PB x cube by 6L, PB x cube by 6L plus C1 is equal to C3, we know. C3 is this much. We will write minus C3 is PBL by 6L into L square minus B square into x, because it is C1x. C1 and C3 are same, and C1 is equal to C3. We have already shown previously, 6L into L square minus B square. This is one equation between 0 less than or equal to x less than or equal to a. EI delta x for the other portion, C4 is 0. We have to write C3 value, PB x cube by 6L, PB x cube by 6L minus P into x minus a whole cube by P into x minus a whole cube by 6 minus C4 into x plus C3 into x. C3 value is minus PB by 6L into L square minus B square into x. This is for a is less than or equal to x less than or equal to L. These two equations we have got. Now, we have to find out the maximum deflection. From the definitions of calculus, for any value to be maximum, d of that value, dy by dx, should be equal to 0, maximum or minimum. Dy by dx, here y is d delta x by dx should be equal to 0. Let us say in the first equation, let us do it. What is the first equation when we integrated only once? When we integrated only once, the first equation is EI d delta x by dx is equal to, first equation is EI d delta x by dx is equal to, please refer to previous one, PB by L. No, first one, not the second one. Integrate once. PB by L into x square by 2 plus C1. PB by L into x square by 2 plus C1. What is the value of C1 we have got? C1 and C3 are same. We have got the value of C1 as previously minus PB by 6L into L square minus B square. Minus PB by L into L square minus B square. 6L. This is the value of C1. This is C1 and this is in the multiples of x. Now, this value is C1. What is that? PB by L into x square by 2 into EI, first equation. What is that we have got? Integrate once, first equation, integrate first time, plus C1 only. PB by L into x square by 2 plus C1. That's what we have got. Now, all the values are there. This should be equal to 0. This we should make it as 0 for maximum deflection. That implies 0 is equal to PB by L into x square by 2 minus PB by 6L into L square minus B square. This is the value we have got. Now we have to find out the x value at which the deflection is maximum. We have to find out the point at which deflection is maximum. PB by L into x square by 2. When you take this to other side, PB by 6L into L square minus B square. This PB by L will go. 2 will be cancelled and 3 will be here. That implies x square is equal to L square minus B square by 3. That implies x cannot be negative, it is plus or minus, where distance cannot be negative, hence we have taken the positive value, square root of L square minus B square by 3. This is the value of x. The question can come in the examination either in GATE or SSC JE asking for the position of the maximum deflection. The position of the maximum deflection in case of above for a point load at A from first support P is at A from first support and total length is equal to L is equal to A plus B. The second support is at B. Second support is at B. Distance L from the first support. Now, the position of the maximum deflection. The position is equal to x is equal to square root of L square minus B square by 3. Please remember this value. This can be asked. And there can be a question also like this. Because this L square minus B square by 3, that value is between x and A. This first support and the point of load. The maximum deflection occurs between the first support and the point of the load. Position of the load. X is equal to L square minus B square by 3, square root of. This is the position. And let us draw the curve, deflection curve. I am drawing only deflection curve. Let us draw the deflection curve. Sorry, it is not cantilever. We have to draw it simply supported. The deflection curve will be, maximum deflection will be here, and this is the point P, this is B, this is A, and this will be the maximum delta x maximum at a value of x is equal to square root of L square minus B square by 3. That means this x is between the left hand support and the load, action of the load. This you please remember. And the maximum deflection is not maximum under the load. There will be a question, when P is the point load, where will be the maximum? Whether the maximum is at the support? No. Is the maximum at the other support? No. Delta A is equal to, this is A, this is B, this is C, this is D. Delta A is equal to 0. Delta B is equal to 0. Delta C is less than delta D. Delta D is equal to what? That is equal to delta maximum at x is equal to square root of L square minus B square by 3. This is what. Now I got the position of the load. Then I can put that value in the, because it is in the left segment or the segment between 0 to A. This is A. This distance is A. 0 to A. I have to use the first equation. What is the first equation? First equation is EI delta x is equal to because the maximum deflection is in the first segment, that is 0 less than or equal to x less than or equal to A. That implies EI delta maximum, delta x is equal to delta maximum, is equal to, what is that equation? PB x cube by 6L, PB x cube by 6L minus PB by 6L into PB by 6L into L square minus B square into x. L square minus B square into x. What is the value of x? X is equal to square root of, for maximum, delta maximum. For delta maximum, x is equal to square root of L square minus B square by 3, square root of. Put this value as above, in the above, EI delta max is equal to PB into L square minus B square to the power of 3 by 2 divided by root 3 6L into root 3. 3 to the power of 3 by 2 is nothing but 3 into root 3 minus PB by 6L into L square minus B square. This value is same as it is, it will be into x, square root of L square minus B square by root 3. This is not root 3, it is already root is there, we have to write only 3. That will be EI into delta max is equal to PB by 6L into L square minus B square to the power of 3 by 2 divided by, because cube is there, 3 root 3 minus PB by 6L we have taken common, L square minus B square to the power of 3 by 2 divided by root 3. One by 3 minus 1 is equal to 2 by 3. Deflection cannot be negative. Hence, this we can even put it in absolute values. Deflection cannot be negative or positive. Let us find out the quantity. That's what is asked. The quantity of the deflection. The amount of deflection cannot be negative. You put it in absolute values or whatever may be, P by 6L into L square minus B square to the power of 3 by 2 also we will take it out. 1 by 3 root 3 minus 1 by root 3. 1 by 3 minus 1 by 3. Root 3 also we can take it out. Then this is equal to PB by 6L into L square minus B square to the power of 3 by 2 into 1 by root 3 also we will take out. 1 by 3 minus 1, that is equal to minus 2 by 3. That is equal to minus 2 by 3 into PB by 6L into L square minus B square to the power of 3 by 2 into 1 by root 3. When 2 by 3, when 2 gets divided by 6, it will be 3. 3 into 3 is 9. That implies EI delta max is equal to PB by 9L root 3, PB by 9L into root 3 into L square minus B square to the power of 3. When you take out this EI on the right hand side, you will get the final answer. Delta max is equal to this PB by 9 root 3 L EI. It will come on to the left hand, right hand side. Then it will be PB by 9 root 3 EI into L square minus B square to the power of 3 by 2. Please remember this formula, the derivation of the formula. Please make a note of it. This is the final formula where it is in the first segment, not at the under the point load, and it is at the first segment, between first support and the point load, that A, the maximum deflection takes place, 0 less than or equal to, in this portion the maximum deflection takes place. That maximum deflection value is this. If the point load is at center, then what happens? X is equal to A is equal to L by 2, not X, sorry. A is equal to B is equal to L by 2. Please put that value in the above. When the point load is at center, delta max is equal to P into L, B is L by 2, 9 root 3 EI into L square is L square only, minus B by 2 is L by 2 whole square to the power of 3 by 2. That implies when A is equal to B is equal to L by 2, when the point load is at center, then delta max, please simplify that, you take it as a homework, please simplify it. Delta max is equal to PL cube by 48 EI. This is very, very, very important formula. For a simply supported beam, when a point load is applied at the center, the maximum deflection will be at the center and that value will be PL cube by 48 EI. For a cantilever beam, it is PL cube by 3 EI. Cantilever beam deflection when point load at free end, that is equal to delta max is equal to PL cube by 3I, which we have derived in the previous class. For simply supported beam, delta max when point load is at center implies delta max is equal to PL cube by 48 EI. There can be a objective type question which also I have explained in the vibrations class in structural analysis. Please see my previous lectures where I have told delta max for above combination simply supported B by delta max cantilever for point load at free end. Here point load is at center. Delta max will be 16 by, this will be 48 by 3, that is equal to 16. This can be an objective type question for you in the examination. What is the ratio of maximum deflection between the simply supported beam and the cantilever beam? Simply supported, the point load is acting at the center, and for cantilever the point load is acting at the free end. The ratio of maximum deflections is 16. Answer is 16. If it is given reverse, it is 1 by 16. Please remember this. Very important. In this class what we have done? One is we have done integration process, we understood, and then deflections we have found, and we have found point of maximum deflection, and we have compared deflection values for similar cantilever and SSB. Of length same, P at free end for cantilever and P at center for SSB. The ratio is equal to 60. Best of luck to everybody. Thank you for listening to my lecture. Thank you for giving this much time for me. And it's Ramchandra from Civil MECH Maths Concepts channel, and my channel name is Civil MECH Maths Concepts. I am an IITian and I will explain these things to the best of my knowledge. I am explaining. Please take advantage of these and do well in the examinations. And there are 61 videos released before this. Please see all of them. I will put in the description the link for the other videos also. And I have done some videos on engineering mathematics also, which is essential for solving certain problems in structural analysis and other analysis in the engineering subjects. Now please subscribe to my channel, and if you feel there is a value addition to your knowledge because of these videos, please subscribe to my channel. Thank you. Thanks a lot. Best of luck to all of you.